All right, algebra crazies. I know you're crazies. Fist pump here, saying hi. So this is Monday, the 6th of April. This is all about MAD, so statistics and parameters. So I'm going to read through a couple of these things, and I'm going to get into MAD, mean absolute deviation. The statistics of a sample are used to draw conclusions about an entire population. This is called a statistical inference. In the scenario above, which you didn't see, each student takes a random sample of pennies from a jar. The jar of 1,000 pennies represents the population, basically the total. A statistic is a measure that describes a characteristic of the sample. A parameter is a measure that describes a characteristic of a population. So statistics, characteristic of a sample. Parameter is a characteristic of a population. Parameters are fixed values that can be determined by the whole entire population but are typically estimated based on the statistics of a carefully chosen random sample. A statistic can and usually will vary from sample to sample. A parameter will not, for it represents the entire population. So there's a difference on that if you ever heard of it. Then I got some identifying samples and population situations described. You can read through all this and see if you have any questions about population sample statistic and population parameter. Pretty easy to understand. I'm not going to go through this example down here under serial, starting with random selected serial boxes. I want to get right into MAD. So over here is MAD. So I'm going to zoom in a little bit so you can see this part. Hopefully it'll focus up. Come on, focus up, dude. All right, see if that works. All right, here we go. Univariate data can be represented by measures of central tendencies, which you just saw in the previous lesson, such as mean, median, and mode. Univariate data can also be represented by measures of variation that assess the variability of the data. This is range, quartiles, interquartile range, mean absolute deviation, which we're going to talk about today, and tomorrow we're going to talk about standard deviation. So that measures the variation of a set of data. The mean absolute deviation, MAD, is the average of the absolute values of the differences between the mean and each value in the data set. There you go. That's a great definition. You'll love that. The mean absolute deviation is used to predict errors and judge how well the mean represents the data. So there's steps to follow to find MAD. So the first step is to find the mean, which is the average. Remember, the mean is your average. Okay. Step 2, you're going to find the absolute value of the difference between each data value and the mean. In other words, you take the mean and subtract each data value, then you take the absolute value of that. Then you find the sum of those, add them all up, and then you divide by the number of values that you have in the data set. So here we go on the first example. This should help you, and you're going to need this because this helps throughout the whole thing. I'm going to do one example here, then I'm going to do another one at the bottom. So each person who visited the comic book shop's website was asked to enter the number of comic books they buy each month. They received the following responses in one day: 2, 2, 3, 4, and 14. 14 looks like to me like it's going to be an outlier. Find and interpret the mean absolute deviation. So the first thing we do is find the average. So we add up all the scores, 2 plus 2 plus 3 plus 4 plus 14, and divide by 5, and you get 5. Then what you do is you find the absolute values of the differences. In other words, what does that mean? It means 5 minus 2. Okay, it's the mean minus the first data point, which is 2 right here. 5 minus 2 is 3. So you have 3. All right here. The absolute value of 5 minus 3 is 2. The absolute value of 5 minus 14 is negative 9, which is 9. Remember, it's the absolute value of the two. This was the absolute value of 5 minus 2, which is 3 again, and the absolute value of 5 minus 4, which is 1. So all you're doing is going 5 minus 2, 5 minus 2, 5 minus 3, 5 minus 4, and 5 minus 14. Take the absolute value of those. Then you add them up. 3 plus 3 plus 2 plus 1 plus 9. I don't like that they didn't put them in order, but oh well. Is 18. This is not good because it's it's an outlier, but that'll work. So now from there, 18, you take that and find the mean absolute deviation. Well, mean absolute deviation. You just found the sum of the absolute deviations. Now you divide by 5 because that's the number that you have, and this gives you what's called the mean absolute deviation, 3.6. What's that mean? A mean absolute deviation of 3.6 indicates that the data on average are 3.6 units away from the mean. This value is significantly influenced by the outlier 14. Told you 14 was going to be an issue because it looked way out there. So you had 2, 2, 3, 4, and then 14. Okay, without the outlier, the data would have a mean of 2.75 and a mean absolute deviation of 0.75. So that's what you're looking for, is how far that average is from the mean you're basically talking about. So here's our next problem. The prom committee kept a count of how many tickets it sold each day during lunch. 12, 32, 36, 41, 22, 47, 51, 33, 37, 49. Find and interpret the mean absolute deviation. So what we're going to do is start out with our steps. So I'm going to slide this over. Step 1. Step 1 was to find the mean. So what you do is add up all the numbers. So hopefully you can see this. You add up 12 plus 32, all the numbers, and you get 36. Then you're going to take each data point and subtract 36. So 12 minus 36 is negative 24. Take the absolute value of that and you get 24. Do the same thing on each data point. 32 minus 36 is negative 4. Absolute value of negative 4 is 4. This is 0. Absolute value is 0. Absolute value of 5 is 5. Absolute value of negative 14 is 14. Absolute value of 11 is 11. Absolute value of 15 is 15. Absolute value of negative 3 is 3. Absolute value of 1 is 1. Absolute value of 13 is 13. So I did all 10 of those. Then you add those 10. If I add all of these 10, I get 90. The MAD is the average of that. So 90 divided by 10 is 9. And that means, on average, okay, this is your answer. I always have the answers here. On average, daily ticket sales are 9 tickets away from the mean of 36 tickets. So before or after that. So 36 minus 9, 36 plus 9. There is your MAD. All right. Peace out.